5,929,225 is a perfect square number. Determine square root of 5,929,225 using division method. So we have a 7-digit number, so it's quite large, and to find out the square root is a little bit challenging. But remember the steps that need to be taken. Okay, so what are the steps? The first thing is to divide the number into pairs. So that means starting from the right, yeah. So that means it's 25, and then 92, and then another 92, and then a lone pair, which is 5 here. So the square root of this number contains how many digits? Can you guess? Of course, it's going to be 4 digits. Remember, the number of pair is 4. So that means the square root has 4 digits. Okay, what is the second thing? Take a look at the leftmost pair, which is 5. So can you guess what is the first digit of the square root? Remember, the first digit when multiplied by itself must be less than the leftmost number. So that makes it 2. Because 2 squared is less than 5 and 5 is less than 3 squared. Okay, 2 squared is 4 and 3 squared is 9. That means the first digit of the square root is 2. Okay, what is the third thing? Take a look at the last digit. The last digit is 5. That means the last digit of the square root is also 5. Because it's only 5 when you square it, it becomes 5 as the last digit. Okay. That means the square root of this number is going to be a 4-digit number that starts with 2, and then 2-digit number, and then ended with 5. So it is only the middle 2 digits that we need to find out, because the first and the last digit are known already. So let's do our division method. So the pairs are 5, 92, 92, and 25. The first digit is of course 2. So 2 times 2 is 4. Remainder is 1. Bring down 92. That becomes 192. So 2 here. Add them up, become 4. And we empty up the next digit. And we need to guess what the next digit be. So 4m times m is going to be less or equal to 192. So what could it be? Can it be 45? Let's figure out whether or not 45 is the number. 45 times 5. So 5 times 5 is 25. This is 22. So 22 is bigger than this. So let's try 44 then. 44 times 4. 4 times 4 is 16. So 16 plus 1 is 17. 176 is less than 192. So the digit is 4. So we have figured out the second digit now. 44 times 4 is 176. The remainder is 16. Okay, so let's bring down 92 here. So it becomes 1692. Remember, the last digit is already determined to be 5. We just need to figure out the next digit here, the third digit. So 44 plus 4 is 48. And let's empty the next digit. So what could the next digit be? Let's try 482. 400 times 2. That is equal to 4. 16, 1, 8, 9. 964 is less than this. Let's try the next digit, which is 483. 3 times 3 is 9. 8 times 3 is 24. 4 times 3 is 12. 12 plus 2 is 14. Okay, still less than this. 1449 is still less than 1692, but it's getting nearer. Let's try 484. I guess this will exceed. I think the next digit is going to be 3. So 4 times 4 is 16. 8 times 4 is 32. Plus 1 becomes 33. This is 3. 4 times 4 is 16. Plus 3 is 19. Okay, now it is already exceeding. So the next digit is going to be 3 here. So 473 multiplied by 3 is 1449. That the remainder is going to be 3 here, 4, 1. So let's bring down 25. Oh, by the way, we have already figured out the last digit, but let's just do it for the sake of completing it. So this, we need to add 3. 483 plus 3, that becomes 486. And the next digit is going to be 5, yeah? But let's verify that whether or not it is correct. Let's do it here in the space here. 4865 times 5. So 5 times 5 is 25. 2. 6 times 5 is 30. Plus 2 becomes 32. 8 times 5 is 40. Plus 3 becomes 43. 3 here. Then 4 here. 4 times 5 is 20. Plus 4. That is 24. Does it match? Well, it doesn't, yeah? It doesn't, because this is 2, this is 1. Okay, let's go and check our steps here. 12 minus 9 is 13. This becomes 8 now. 8 times minus 4 is 4. 6 minus 4 is 2. Okay, so I got this one wrong. So this is 2. That means this number actually match with this. So if we complete this, this becomes 24325 with the remainder 0. So finally, we can give our answer to the question here. Square root of 5,929,225 is equal to 2,435. Okay, it is a very long number, but we are able to find out the square root of it in about roughly 10 minutes. Okay, in the next two examples, we are going to inspect numbers that are not perfect squares, but they lie in between two perfect squares. So there are a certain quantity that needs to be added or deducted to make them perfect squares. And we are going to figure out the quantity that needs to be added or deducted in the next two examples. So stay tuned.